Okay, good afternoon. So, I would like to begin the lesson first. But, in case, meron bang tanong dun sa quiz pa? Or you can address it now about the points we're checking. Or if you want me to answer or show the solution to one of the problems there, you can do it now. Okay, sige, start muna tayo ng siguro. Lesson. Okay. Okay. So, module 5 na tayo. We start with antiderivatives. And they are the opposite of derivatives, as suggested by the name, antiderivatives. So by definition, you call a function capital F an antiderivative of another function small f if the derivative of capital F is small f. And of course, this should hold true for all x values. So to illustrate, suppose you are to find all the possible antiderivatives of the function 3x squared. Now we're not looking for its derivative. You can quickly give the derivative of small f as 6x. Now we're looking for a function whose derivative is 3x squared. So we're undoing the derivative. So antiderivative is like an inverse operation of the derivative. Now we can do this by trial and error. And it's not hard to see that the derivative of x cubed is 3x squared, and therefore it's an antiderivative. Now, the question asks all possible antiderivatives, meaning the antiderivative is not unique, unlike the derivative, which is unique. There are a lot of functions whose derivative is 3x squared. In fact, there are infinitely many. Okay, can you hear me?
Yes, sir.
Okay, sabi kasi connection is unstable. Anyway, please tell me if I'm choppy, okay? So
Okay
another
po.
one is x cubed plus 1. If I differentiate x cubed plus 1, I still get 3x squared since the derivative of a constant is 0. And in fact, you get the idea that if I just add to x cubed any constant, it will result in the same derivative. Like pi, derivative of x cubed plus pi is also 3x squared. And in general, instead of having to give a specific antiderivative, we just denote all possible antiderivatives by adding a constant c to one of the derivatives, in particular, the one that has 0 for its constant, the x cubed. Actually, this is x cubed plus 0. And so we write x cubed plus c to denote all the antiderivatives of small f. And again, if we differentiate this function here, we get the derivative as 3x squared. Now, there's no other way of getting another antiderivative but by adding a constant. And thus, all antiderivatives will differ from each other by just a constant. If I subtract, for example, the middle functions, the result will always be a constant. And that is stated here in this theorem, okay, which says or states that if two functions f and g. Okay, this should be equal to, if two functions, capital F and capital G, have equal derivatives. If I differentiate capital F and I differentiate capital G, I get the very same function, and that holds true for all x values in the domain. Then my conclusion is that these two functions only differ by some constant value. So anyway, this theorem is not really that needful for you to study. It's only needed for formality. And so this time we will just be writing down all the antiderivatives by adding a constant c to a given or a specific antiderivative. So for example here, find all possible functions f whose derivative is x to the 4. And you know that that function must be 1 degree higher. So it has something to do with x to the 5. But if we differentiate x to the 5, we won't get x to the 4, but a multiple by 5. So you have to adjust. And so you know that the proper or a specific antiderivative is 1 over 5 x to the 5. And therefore, we write down all possible functions by 1 over 5 x to the 5 plus c. A spatial notation is given by this curl symbol. You read it as curl or just the integral actually. It's read as the integral. So let's read the definition. The family of all antiderivatives of a function small f is denoted by this symbol, curl f of x dx, or integral of f of x dx. That is, the function there is simply capital F of x plus c, where capital F is a specific antiderivative. In other words, it's just a spatial notation to indicate all the antiderivatives, as already illustrated in the previous example or examples. So for example, we got x cubed plus c as the family of antiderivatives of 3x squared. So we denote that by putting the curl symbol here and the operator dx. So this means all the family of all antiderivatives of the integrand. You call this the integrand, 3x squared. Similarly, the family of all antiderivatives of x to the 4th or integral of x to the 4th dx is 1 over 5 x to the 5 plus c. Now let's have the power formula. If n is any real number not equal to -1, since this denominator will become 0 if n is -1. But otherwise, if n is any real number, then the integral, I forgot the operator dx, although some textbooks omit the dx and just write the integral. But the integral of x to the n dx is obtained by adding 1 to the exponent, but dividing by the same exponent, plus, of course, c. Now, this is the opposite of the inverse of the power formula for derivatives. For the power formula for derivatives, you bring down and then subtract 1, or you multiply, then you subtract 1. This time you divide and add 1. So for example, x to the 7, what is its integral? Okay, we will use the words or terms integral and antiderivative synonymously or interchangeably. So you add 1, then divide by the same. Simplify. You can check, differentiate this one, bring down 8, subtract 1, you get back to x to the 7. Square root of x dx, the power formula can be used since radicals can be written as powers or exponents. X to the 1/2, add 1, divide by the same. Simplify. Any questions so far on the power formula? Another one, how about this? What does this mean? You just see the operator dx there. There's no integral. So as in algebra, if you write x, you mean 1x, right? 2x means 2 times x. 3x means 3 times x. So if you just see x, there's actually something multiplied to x. It's 1x. So it's 1 dx. So the integrand is 1. And how do you integrate 1? You just find a function whose derivative is 1. Anyone? What function, if differentiated, gives 1? The constant as a derivative.
X plus C.
There, x specifically. So plus c for all the possible derivatives. Or we can apply the power formula if we want. 1 is anyway x to the 0. So you add 1, divide x plus c. Some properties of indefinite integrals. Indefinite since later on we will have definite integrals where you put superscripts and subscripts which have something to do with areas of curves, which you need not bother yourself with for now. So this is the first property here is similar to the one we had for derivatives, where the derivative of a constant times a function equals the constant times the derivative of the function. Same thing for integrals. So integral of a constant times a function equals the constant times the integral of the function. You can take out the constant, in other words, out of the integral sign, the curl here. Now, similar to derivatives, the integral of a sum or difference of two functions equals the sum or difference of the integrals of the functions. Let's illustrate. This is a sum or difference, so we distribute sort of, okay, using those properties. We distribute the integral sign. We have that. And then constant times a function is applied for the first term. Take out 6. Take 6 out. You cannot take x to the 5 out, by the way. That's a common error students make when evaluating integrals. They take out x to the 5 and leave 6 and get a wrong answer after. You can only take out constants from the integral sign. So 6 times x to the 5 dx. Then this is converted to power form, x to the negative 1/2. Then 2 is taken out of the integral sign. You have the dx as we had in the previous example. And then apply the power formula for each. So add 1 to the 5, add 1 to negative 1/2, and then the integral of dx is x. So 2 integral is x, 2x. Then you put the constant later. Just one constant is needed. You don't need to put plus c sub 1, plus c sub 2, and then plus c sub 3. Anyway, c sub 1 plus c sub 2 plus c sub 3 is a constant, which you can just denote by just one c. So you put the constant, you call it the constant of integration at the end, and then simplify. There. No need to write in radical form. Exponential form is acceptable as an answer. So you can leave this as x to the 1. Any question for this one? So some more formulas for exponential and logarithms, logarithmic integrals, functions. So remember, the derivative of e to the x is e to the x. So one antiderivative of e to the x is itself, but there are a lot, plus constant of integration. And we know that the derivative of ln x is 1 over x. So therefore, an antiderivative of 1 over x is ln x. And then to get them all, add c. Now, why did we put an absolute value here? Since the logarithm is not defined for negative numbers. So I will explain that more later when we have specific examples. So let's evaluate that indefinite integral. Distribute the integral sign. Simultaneously take out the constants. Convert this to power form. And then we apply the formulas we already have. For x to the negative 10, add 1 to the exponent. Integral of e to the x is e to the x. Integral of 1 over x is ln absolute value of x. And then c at the end. Simplify. Do not remove the absolute value symbol. You can leave this in exponential form. No need to write as x over x to the 9. I'll give a seat work at the end. That's why I'm already giving you all the formulas. So remember, the derivative of sine is cosine. So the antiderivative of cosine is sine, or an antiderivative. So just add c to get them all. Similarly, the derivative of cosine is negative sine. So the derivative of negative cosine is sine. Therefore, an antiderivative of sine is negative cosine. Antiderivative of secant squared x is tangent x, since the derivative of tangent x is secant squared x. And we'll just discuss one more. This will be the only trigonometric integrals, I think, that will be included, since the rest are just co-functions. So these are the major ones. So we'll include tangent, okay, or secant squared, because it's the derivative of tangent. And one more, the major one. Kasi meron siyang co-function. So di ba may sine then cosine, although we included cosine. So we'll just have secant, not cosecant, and not cotangent. So we know that the derivative of secant is secant x tangent x, if you still recall. So vice versa. Secant x tangent x dx is secant x plus c. Let's evaluate. Distribute the integral sign. Okay, diniretso ko na pala dito. So integral ng cosine x, sine x times 2. Integral of sine x is negative cosine x, and then there's a negative sign outside times the 3. So 3 cosine. Integral of e to the x is e to the x times 5. Then constant of integration. Direct lang yan. Now, I give you time to work this out. Say 3 minutes.
Nag-communist ba yun?
Okay, just have to distribute. So multiply secant x is secant squared x. Then you have secant x tangent x here. And we already have the formulas. So for secant squared x, that's tangent x, and for secant x tangent x, that's secant x. Any question? Now, lastly, we'll have the, integration by substitution. This is the counterpart of the, what they call this, chain rule for derivatives. Remember, for chain rule, you differentiate the function, or you apply the formula, then you differentiate the inner function. Okay, if you have a composition of two functions, that's the essence there. Like if you differentiate a power, you bring down, right? Subtract one, but differentiate the base. So we will undo that here. So as an illustration, let's consider the integral of 2x plus 1 squared with respect to x. One way would be to expanding 4x squared plus 4x plus 1, then differentiating term by term, we get that. That's one way. However, the disadvantage of this one is that it only is applicable if you have a very small exponent like 2, or at most perhaps 3 or even 4. But if you have 10 or more, or especially if you have like higher values like 100, then you wouldn't dare expand everything, the term, since it will contain 101 terms. So that's why we need to resort to another technique, which we call integration by substitution. Here's how it works. Okay, can you hear me?
Yes, sir.
Loud and clear?
Clear, sir.
Okay. So what we do is change variables. We call this a dummy variable, where instead of integrating with respect to x, we'll be integrating with respect to u. And we have to choose carefully u so that the resulting new integral will be easy to integrate. So first, we need to get the differential. Remember differentials? What's the differential due? 2dx. This is just differential. You differentiate 2x, that's 2, times dx. And then we'll convert everything in terms of u. Oops, sorry. So note that, or observe that 2x plus 1 is u. Okay? So that's actually u squared. But note that, or observe that, I have multiplied this by 2, and I put the reciprocal of 2 outside. Why? So that I will have the 2dx appearing here, which will become my du. But of course, to balance, or not, so as not to affect the value, we multiply by 1, so it's still the same as this one. 1/2 times 2 is 1. And then, again, this is u squared. So you have the u squared there. This one is du, and then you have the 1/2 outside. And this looks familiar now. It's just a power, so you use the power formula. So you add 1. By the way, you just use the power formula directly, since notice the operator is also u. So you just apply it directly. So add 1, divide, plus constant of integration. I put C2 since we already used C1 here. And then simplify, 1/2 times 1/3 is 1/6, then revert back to x. Then you have it. And this is our answer. As you may observe or notice, it seems that the answers we obtained are different, but not really. Let's expand this one. Cubing you'll get this. You can just verify that. And then simplification gives the same. Note that the first three terms, except the constants, are the same. So no worries, since remember, integrands or antiderivatives only differ by a constant. So it's only the constant of integration that differ. So there's no problem with that. In fact, we can just set c sub 1 equal to 1 over 6 plus c sub 2, and they will be equal. So again, the first one works only for small exponents. So like this one, yes, there's a question. Okay, so nasa differentials yun eh. Let me, okay, siguro explain ko na lang. Yung u was set to be equal to 2x plus 1. Now differentiate 2x plus 1. Anong derivative ng 2x plus 1? 2. Yun lang siya. Tapos may dx lang. It's like du over dx equals 2, di ba? Tapos i-cross multiply mo.
Okay, sir. Thank you.
So, parang kinross multiply. Pareho lang yun. Pag binaba mo si dx sa baba, di ba? Du over dx lang siya. And ang derivative ng du, ng u with respect to x.
So du over dx equals 2 tapos na
Cross multiply.
you got rid of the yeah. Okay. Thank you, sir.
Ganun din sa lahat. Now here, it's raised to 5. So pwede rin namang i-expand pero mahabang trabaho yun. So we'll use substitution para mas maganda rin yung sagot. Compact din yung sagot. So we set, hindi pwedeng iba ang gamitin mong u dyan. Hindi rin pwedeng pati yung 5 isama mo. Yung base lang. Now, differentiate mo yung u with respect to x, di ba? 3x squared. Tapos cross multiply. So, parang iniba ko lang yung itsura. Differentials yan tinakil. Di ba? Pag nag-estimate ka ng error, nagiging delta x to. So, kailangan, the 3x squared must appear. And there's a 12x squared. So, I'll rewrite. So notice it's still 12x squared 4 times 3. But we need to make the 3x squared dx appear because of this differential. So that this whole thing is just our du. So converting, this is now u to the 5, and then this is du. And constant outside 4. Power formula. Simplify, revert. That's our answer. You can check, undo it, bring down 6, subtract 1, differentiate the base, lalabas ito. Okay, how about if we have a trigonometric integral? You have to choose carefully. Now, anyone can suggest to me what is the right substitution for this integral? That will work. Dalawa lang naman ang pwedeng pagpilian, cosine t or 1 plus sine t. Which is it? Anyone? If you let u be cosine t, what's the derivative of cosine t? Negative sine t, di ba? But this is 1 plus sine t, so it won't work. But if you denote u 1 plus sine t by u, then notice if I differentiate, derivative of 1 plus sine t is cosine t. And that cosine t dt is the one here. So I can rewrite now. Okay, this one is this one, and this is du. So see what happens. So cosine t dt is du. This is 1 over u. U is set to that. And familiar integral, ln, absolute value lagi kapag nag-i-integrate. Ln, absolute value of u plus constant of integration. Revert back. Yan. Laging dapat may absolute value symbol. However, in this case, we can just omit the absolute value symbol since the one inside is always non-negative. Can anybody explain to me why 1 plus sine t is never negative? because sine t ranges from what values? From -1 to 1. So the smallest value sine t can take is -1. So this can be only as small as 0. So actually you can just omit. However, I won't be technical with that. You can just retain the absolute value symbol. Unless when we go to differential equations where we need to do that. Okay, one more before a seat work. Okay, anyone can tell me what is the proper substitution for this one?
Two plus e to the z.
Okay, yes, 2 plus e to the z. Okay, now, if that is chosen, then differentiate 2 plus e to the z with respect to z, you get e to the z. And then convert. There's really not much, what do you call this? I forgot the term. There's not much manipulating to do, but you just rearrange e to the z dz. And e to the z dz is the du already. And this is just, the one inside is u. And we already know the integral of secant squared, tangent. Revert, you're done. Any question? So exercises. There. Okay, sige, I'll give you time. Once you have an answer, paki-chat sa akin para ma-check ko. The numerator is a plus. Okay, let's answer. Okay, for number 1, okay, let u be e to the t minus e to the negative. Anyway, anybody answer? Okay, correct. Number 1. So that means if you differentiate, derivative of e to the t is e to the t. Derivative of e to the negative t is e to the negative t. Don't forget, derivative of negative t is negative 1. Then multiply by dt. So this will serve as your du, which in fact is this one. Math. So if you rewrite, you'll have integral of du over u, or 1 over u. Du. So ln integral lang siya talaga. Revert. That. Nice. For number 2, let u be the base of the denominator. Since the derivative of sine t plus cosine t will be this one. And then this will be du. And then this is raised to negative 5. Exponential form. So it's the u integral will be exponential with a negative exponent. This is du. And then ito yung u to the 5, which is in the denominator. So if you write it as an exponent, it's to the negative 5. Then power formula. Revert. No need to simplify further. You can use negative exponents and fractional exponents. And then number 3, you can just review the video. You got lost. What's the proper substitution? Anyone? Let u equals
1 plus tan y.
okay, 1 plus tangent. The derivative of 1 is 0. Derivative of tangent is secant square. Then d1. Now there's no secant square but your guess has to do with something with this. You have a cosine squared y dy, but du is secant squared y dy. But they are reciprocals. Don't forget, 1 over secant theta is equal to cosine theta. They are reciprocals. So we can first rewrite integral of ln 1 plus tangent y dy over secant squared y. Okay, sorry. This is a wrong problem. It should have been below. Get me. I just designed this problem. It's supposed to be secant squared. That will have been. Anyways. So dapat nandito siya, sorry. So kung nandyan yan, lalabas yung secant squared. So this now is the one we're considering. So i-rewrite natin yan. ln 1 plus tangent y, and then the over cosine squared y can be written as secant squared y. This is now your du. So we convert ln, integral of ln u du. Okay, something's wrong with my calculation. Okay, I made a wrong problem. Not this one. Okay, but actually this one is integrable, but it can only be done using the technique of integration by parts. But I don't think that will be included. So let me show you what I really was thinking. Gusto ko kasing gamitin si LN. Okay, it will become a complicated integral. This is what I have in mind. Okay, magiging mahirap, magiging complicated. So I guess the only way to make up for that is by removing the ln. Then yun, lalabas siya. du. Then u. U squared over 2 plus c, so yun. Okay, that's it. Now, sino may tanong doon sa graded exercise? Kung wala, so that's it for today.
Sir, for the quiz po, may questions po yung class.
Ah,
Um, oh, the others here, do you have questions muna? Or
the
okay,
score
seems like
or the solution or ano yung
solution po sana, sir. For
pakita natin?
apo, the one with f of x and g of x.
Ah, okay, yes. Ah, sige. Actually, nandun yun sa ano, kasi dahil nga hindi siya upload file, dapat lalabas yun as you solve it eh. Kita na siya dapat. Pakita ko na rin. May nakakuha nun eh. So, quiz 1. Ah, sorry. Ano pala kayo calculus? Which one? Kasi apat na ano yun eh. Set. Yan.
I think the third one po.
Third one, okay. Okay, so what's the derivative of inverse tangent?
1 over x squared po.
1 over 1 plus x squared. So ito, 1 over 1 plus e to the y squared. And then don't forget, differentiate e to the y. Oops. So derivative of e to the y is e to the y. Then you have y prime. Chain rule. Basic differentiation to ha. Then 0 na to. Then differentiate natin si ln. Reciprocal. Then differentiate mo si yung nasa loob. Lagay ko na lang sa numerator. Di-differentiate ko si xy. And then, di ba, i-collect natin si y prime. So, ito kasing right-hand side, ihiwalay ko si y prime. Then, ko-collect ko yung mga y primes. Then, ito, e to the 2y na yan. Then, transpose to. So, if you compare, wait. So, ano yung f of y? Nagmamatch, di ba? Can you see it? That f of y is this?
Oh, yes, sir.
Then yung g of y mo, this one. Kasi you have to find f of y and g of y. At para magpareho talaga yan, kailangan talaga mag-i-match mo yung kung ano yung nandun sa solution. Yan, kasi hindi siya file upload question. So, kailangan mong hanapin dun sa solution. Anything
Okay po.
else?
I have 2 questions po about this.
Okay, sige pa. Ano pa yan?
It assumed po agad na dapat derive in terms of x, right?
Anong question na ito?
No, this same question po dito sa kasi dinerive niyo po siya in terms of x. Though hindi po nakasabi sa instructions. So yung answer po ng iba, iniwan po nilang x prime.
Anong x prime?
Oh, hindi po nila tinanggal yung x prime. Iniwan lang po nila yung x prime.
Bakit nagkaroon ng x prime?
Kasi po, wala
Kasi
pong
we're
sinabi to
differentiating
derive.
with respect to y, to x.
Wala pong sinabi to differentiate in terms of x po. Actually, sinabi lang po if tan find f of x. Wala pong sinabing to differentiate. So, is it okay po pag iniwan nila yung x prime?
I-differentiate natin with respect to x?
Hindi po din-differentiate in respect with anything. So iniwan lang po nila without differentiating in terms of x. So yung answer po nila for g of x, y, answer po namin is x y prime plus x prime y.
Yung unang part ng solution?
Opo.
Ito?
Opo.
Hindi siya pwede kasi nga you're looking for the value of f of y and g of y. Kaya naka f of y siya. Napansin mo, ibig sabihin in terms of y. Kung nakalagay siya f of xy, yun pwede siguro. Kaso may y prime pa nga yun. So kasi attempt to solve this problem, yun nga, kailangan mong mag-solution. So ito yung magiging solution natin. Lalabas talaga yung first line na to. Yan. And then, ang tendency mo talaga dito, hanapin si y prime. Kasi yun naman talaga yung ginagawa natin. We're looking for y prime. So that pwede mo siyang i-ano sa y prime dito compare nandito na y prime. So talagang maglilipat-lipat ka and eventually dito ka darating. Para ma-solve mo pa nga si y prime, you have to divide by this. But then, dito pa lang mapapansin mo na yung similarity. Yan siya. Actually, ang quiz kasi, it's not only a test of what we have tackled in class. It also tests yung understanding pa rin din naman. So kapag sinolve mo siya, tapos magbigay ka ng konting time dito, mag-appear dapat sa mind mo yan, yung sagot. Then mako-compare mo na yung yan. Mapapansin mo sina 1 plus e to the 2y, and sina y. Yan, titignan mo yung taas. Meron bang tanong?
Okay. Meron pong isa nag-send po sa akin. Glitch po ata. Wrong answer. Sa question number 2 po. The one with an interval sa 0 to 4.
Anong nangyari sa kanya? Yung merong choices? Yun ba yun?
Hindi po. Yung answer po na y.
Ano yun? Nag-wrong checking lang si Canvas?
Wrong check. Wrong po yung
Paki-email
nakalagay
niyo
sa...
na lang ako, sabihin mo.
Okay po.
Or ano mo sa akin, yung pangalan ng student at anong number
Okay po.
yung inaano niya.
Okay po.
Kung sa kanya lang naman yun.
Okay po.
Others, meron pa ba? So I guess wala na, no? So kung merong checking lang talaga yung point system, siguro pwede namang email lang ako doon sa Canvas. Okay, so that's it.
Okay po, sir. Thank you po.